Something about Mars has captivated humans throughout history and still does. And most crucially, it became a possible utopian dream destination for those seeking relief from Earth's falling apart. But Mars is no place for the faint-hearted. It has taller volcanoes, deeper canyons, colder deserts, and never-ending storms. Everything about it screams adventure, and somehow it is still irresistible to us. Creating a habitat on Mars used to be a dream, but nowadays it has become an urgency for humans. It seems like everyone on Earth wants a piece of land on the red planet. No wonder why the race to conquer Mars is heating up.
By the mid-2030s, I believe we can send humans to orbit Mars and return them safely to Earth.
Touchdown confirmed. Perseverance safely on the surface of Mars.
Colonizing Mars.
NASA wants to send humans to the red planet by 2030, and Elon Musk's SpaceX and 2 other Californian startups want to get there even sooner, with plans to space travel there by 2024. However, the biggest question still remains: if we successfully land on Mars, then what? First, we need to understand that Mars is the most habitable planet in our solar system after Earth. Although Mars is hundreds of degrees colder than Earth. Plus, humans would be unable to breathe it to survive because oxygen is only 0.13%, compared with 21% in Earth's atmosphere. Mars' atmosphere is dominated by carbon dioxide at a concentration of 96%. Other difficulties and hazards include radiation exposure on its surface, toxic soil, low gravity and isolation from Earth, lack of water, and cold, hot temperatures. However, research suggests that billions of years ago, when life emerged on Earth, the climate of Mars could have been Earth-like as well, with a thicker atmosphere than today and oceans of liquid water. So there is a chance of an Earth-like Mars, a future of terraforming. But those days are far in the future, if they even happen at all. That's why instead of asking, is Mars going to be habitable or not, we should be asking, can we make it habitable? The answer is definitely maybe, and must be done through technology with rigorous steps. Traveling to Mars is just the first leg of the journey. Although Earth and Mars are the second closest to each other in the solar system after Venus, a one-way trip to the red planet would take about 9 months. That's 18 months for a round trip. The distance between Earth and Mars fluctuates between 55.6 million and 101 million kilometers due to its highly elliptical orbit. We must have a solid plan to make sure that by the time we reach the distance of Mars' orbit, Mars is where we need it to be. Practically, this means we can only begin your trip when Earth and Mars are properly lined up, which unfortunately only happens every 26 months. Yes, we got only one launch window every 26 months. On top of that, today's technology is nowhere near good enough to go on a journey to Mars. Once we get there, the challenge becomes landing on the planet's surface. The atmosphere on Mars is equivalent to about 1% of the Earth's atmosphere at sea level. That makes getting to the surface tricky. Today's lander is so heavy that many technologies, such as airbags, sky cranes, and parachutes, are completely useless. Part of the ability to reach Mars by 2040 will depend on new nuclear-powered propulsion technologies that could reduce flight time and land on Mars more effectively. The good news is NASA plans to test a spacecraft engine powered by nuclear thermal propulsion technology by 2027. But once we make it to Mars, what comes next? Can we really build a habitat? The first step would be to build a habitat that will prevent toxic dust from getting into astronauts' lungs. Microbial life and exposure to cosmic radiation from the Sun and Mars itself is another life-threatening problem out there. With all this in mind, scientists involved with the Mars mission will take these and other potential risks into consideration. Astronauts on board the International Space Station recently conducted an experiment that showed they could successfully mix cement in microgravity, which can indeed solidify, much like it does on Earth. It opens the door to developing better ways to manufacture the substance in various gravitational environments. And if humans are to build a moon village or a Martian colony in the years to come, we'll likely need to master mixing cement on other worlds. One step toward a habitable structure would be to develop a super tool that could be used to quickly manufacture any other desired tool or object. And this is where 3D printers come in. Recently, NASA unveiled the Mars habitat for year-long experiments on Earth at Johnson Space Center in Houston, Texas. On June 25, 2023, a crew of 4 volunteers entered a simulated Martian habitat called Mars Dune Alpha, which is a 1,700 square foot 3D printed living space. The crew will live, work, exercise, sleep, and perform experiments. The company behind the technology is ICON, a Texas-based construction company specializing in 3D print construction. NASA and ICON have multiple contracts. In 2022, NASA awarded ICON a nearly $60 million contract to develop Olympus, another 3D printing system specifically designed for building on the Moon and Mars. The company hopes to be building on the Moon by 2026, with the first structure likely to be a launch and landing pad. Now imagine, NASA base is well established on the Red Planet and the astronauts learn survival basics. But things get more interesting here. They need a farm on Mars, which will be greenhouses to protect the plants against the challenging Martian environment. Martian soil isn't like the soil on Earth. It lacks the organic, rotting biological materials that plants need. The soil will also need to be cleansed from toxic materials. Detoxified soil isn't the only thing astronauts will need to grow plants. Yes, water. Lots of water. Luckily, there are regions on Mars with large cross-sections of ice deposits below the planet's surface. Many scientists anticipate that the first human base will be located close to these billion-year-old ice deposits so that humans can easily produce the volumes of water that they will need to support water-intensive activities like farming. The technology to extract water locked in Martian soil doesn't exist yet, but NASA hopes to bridge that gap through its Mars Ice Challenge. A team from West Virginia University won the 2019 competition for their prototype, which was able to identify and drill through various rocky and icy layers and then extract water from an ice block. Also in July 2019, NASA, along with the University of Central Florida and Honeybee Robotics, showed off a prototype spacecraft the size of a microwave oven called The World Is Not Enough, or WINE. It's designed to mine soil on asteroids and extract water from the soil. The technology could be adapted to harvest water for Mars exploration. For now, Mars has no inner atmospheric dynamo to sustain life. But some people believe we might be able to make Mars habitable through terraforming, a hypothetical process of altering a planet to be Earth-like enough to support human life through releasing greenhouse gases in a planet's atmosphere or placing a device that creates a magnetic field to thicken the atmosphere and heat up the planet. And there are several crazy proposed ideas. Like SpaceX CEO Elon Musk has famously suggested dropping nuclear bombs on the Martian polar ice caps. In theory, it could work, but it's also been criticized for both the large number of nukes required and the possibility that it could backfire, creating a nuclear winter on Mars. None of these ideas for terraforming Mars have gone anywhere beyond the proposal stage, and it may ultimately be impossible to turn the Red Planet into Earth 2.0. But Mars isn't our only way. On a grander scale, it is almost certain that humanity will one day colonize the Moon, Mars, and potentially even Venus. Therefore, Mars colonization is a challenging task that would lead to the development of many innovative technologies and will create opportunities for multiplanetary space exploration.